of motion. Let me just show you this. If you can see it, maybe inshallah you will see it. See how the car is moving when it hits. No, not this one. This is not what I want, but let me just share. It's not coming. Let me just bring it here. Okay, let me just now share. Share application screen. I hope this one will work, inshallah. Yeah, now I think you can see the screen. I hope it will work. See, we are assuming that this is the chassis of the car here, and we have a spring and damper, and the wheel is here. It hits a bumper like this one. Now we have two plots. The upper one is the displacement of the car. The lower one is displacement of the road. If the road hits the bumper, see what's going on here. Do you see what's going on in the screen, Shabab? If you, for example, you hit a sinusoidal wave like this one, do you see, Shabab, what's going on?
Yes.
Oh, okay. So this is the motion that is transmitting from the ground to the car. So as we have seen last time, if you remember, Shabab, we said when we increase the speed, the motion gets smaller. Let me see if I increase the speed, what will happen. See the amplitude of the motion, how it will get. The amplitude of the car, the force transmitted to the car is small. Although the force transmitted from the road is large, but for the car is very small amplitude. So now if you want to hit a bumper, maybe you have experience on that, I don't need to tell you. If you go at high speed, you don't feel that you have a large displacement. It will be a very slow displacement. So this is basically what we are going to see today. تفضل هاني.
زاد فضلك يا دكتور. طيب, will it have a large impact on the car?
Of course, yeah. Of course, and you will deteriorate, you will damage your suspension system. لأنه high speed is not required, but it has good thing that you will not. The displacement is slow, but it will damage your system components, which are the dampers and the spring. If this is clear, Shabab, I will go back to my files. Do you see what we are going to see today? So the force transmitted from, not the force, the motion transmitted from the ground to the car. Now, if I increase the speed, this is what is happening. If I increase the mass, if I increase all the parameters, this is how it happens. And if you are hitting a bumper, this is what you see. If you see an obstacle, this is what you have. And if you go smoothly on the road, like we do here in KFUPM, this is what we see. It's not like what we do in downtown in city, we do this. So if we go back now to our notes, we will share the files. So this is what we have, Shabab. So we will see now, if we assume our car to be a mass spring damper system, you have seen this one. Now this is the profile of the road, and this is the isolator we are putting here, which is the mass, the spring and damper. So the equation of motion will be something like this one. We have the, assuming the force that is sinusoidal here, P sine omega t, this is the input to the system. And we have your mass here. If you draw the free body diagram, there will be a relative motion, Shabab, hina. Maybe you don't need to explain you to this, but it's good to have it. If this is the mass here, so, and the car is going down like this, so there will be a force on the spring that is in this direction. So this is the motion, and this will be the force on the spring, K x minus P. And this one will be B x dot minus P dot. So this is the mass here. And if we write Newton's second law, sigma, force will be equal to mass times acceleration. We will have the forces minus K times x minus P minus B x dot minus P dot is equal to mass times acceleration. If you arrange this equation, if you rearrange this equation, you will get this. So mx double dash plus bx dot minus p dot plus kx minus p. Why here we have x minus p and x dot minus p dot? لأنه the two ends of the spring and the damper are not fixed. They are free to move. So they move relative to each other. X moves relative to p and p moves relative to x. That's why we have x minus p and x dot minus p dot. So at the end of the day, if we rearrange it again, we will get like this. Mx double dot plus bx dot plus kx is equal to bp dot plus bkp. So the right-hand side always contains the input, and the left-hand side contains the output. And if we take Laplace transform of both sides, so we'll have ms squared plus bs plus kx of s is equal to bs plus kp of s. And if we take the transfer function or the ratio of the output over the input, we get bs plus k over ms squared plus bs plus k. This is the transfer function. Now the sinusoidal transfer function, just substitute kg omega, substitute s by j omega, and you will get the following, which is this one. xj omega over pg omega will be bg omega plus k over k minus m omega squared plus g b omega. So this is the sinusoidal transfer function, and the amplitude of the steady state will be xj omega. The amplitude of the input will be this one, and the transmissibility ratio of the, it is the amplitude of the output displacement, which is xj omega, over the amplitude of the input displacement, which is simply amplitude of the numerator, b square omega square, plus k square under the square root, over k minus m omega square plus b omega square. So this one will be exactly in the same form that we have found for the force. We found for the force, if you remember, that the transmissibility ratio was equal to this amount. Here it's the same, is equal. It is exactly the same transmissibility ratio. As an example to that, rigid body, so we agreed that the transmissibility ratio is same for both, either for the force that is transmitted or for the motion that is transmitted. It's the same. So TR will be 1 plus twice zeta R, the whole square, minus 1 R square, the whole square plus twice zeta R square. As an example to that, a rigid body is mounted on an isolator to reduce vibratory effects. Assume that the mass of the rigid body is 500 kilogram. The damping coefficient of the isolator is 0.001, very small damping, and the spring constant is 12,500 Newton per meter. Find the percentage of motion transmitted to the body if the frequency of motion excitation of the base of the isolator is 20 radian per second. So this is the omega, and we need to find omega n. Omega n is known to be square root of k over m. So it is 12,500 divided by 500. This will give you 5 radian per second. R is equal to omega over omega n, or the ratio, the frequency ratio is 4. 4 is greater than square root of 2. So we are in the isolation region. Isolation region, I'll bring it back for you to see it. If you remember, we said when R is greater than square root of 2, we will be in isolation region. So this is what we have here now. R is equal at this region here now, 4. R is equal to 4. And zeta is 0.001. 0.001 is maybe this one here. So the isolation will be in the range something here. So we will see now the equation. What does it give us? And the graph will give you this. Since R is greater than 4, you are in the isolated region. So when zeta is equal to 4.01 and R is equal to 4, we substitute in the transmissibility ratio, and we will find that the percentage is 0.0669, which means that the isolator reduced the vibratory motion to 6.69% of the vibratory motion of the base isolator, which is any good to have 6% isolated of the vibration motion. So the vibration of the body is reduced to 6.7%. When we talk about this one, Shabab, isolation, and we also talk about dynamic vibration absorber. Dynamic vibration absorber, sometimes you are working in a region, and this region, Shabab, your operating region, I will just give you something like this one. This is the omega over omega n, omega over omega n. And you have a machine that works at 1,500 RPM. 1,500 RPM. This is your working frequency. This is your working. At this 1,500 RPM, it happens that you obtain the resonance. This at 1,500 RPM, you obtain resonance. So in this case, what we do, we will put an absorber. This absorber, the objective of this absorber is to absorb the vibration that is making your system having the resonance. So usually this type of absorber, we will see it in a minute. You will see it happens in the application in a reciprocating machine, in building excited by earthquakes, transmission line or telephone line excited by wind or buildings. You have bridges. These are the absorber. Usually we put mass with the spring. In the transmission line, maybe you have seen this one when you go by car from here to Medina, or from here to Al Qasim, or from here to Jeddah, or from here to Riyadh. You may, if you look to these transmission lines, the power lines, you will see these ones. This is simply a mass with the spring, small spring that absorbs the high vibration that are coming from the resonance system. Also in the high buildings, you see them here. This is called the Taipei 101 building, which is this one, Shabab, exactly. And this is the absorber. They are putting it in the floor 101. So that's why it's called 101 building. I think also it's there in Burj Khalifa. Also it is in Mecca Tower. They put in to avoid the high vibration that excites the building, and that it will go to resonance, and then the building collapse. So what they do, they put this absorber to absorb the vibration. So I'll show it to you now. Suppose here now we just take small effect. So we assume that our machine or building is like this. It's just a building, and it has a mass, and it has a spring effect. So this is the model, mass and then spring. You see, Shabab, here, the natural frequency of the system is simply K over M. and we assume that the building is affected by a force P naught sine omega t. Omega is the frequency of oscillations, which is the forced frequency, and omega n is the natural frequency. So the resonance here happens, the resonance happens when we have omega is equal to omega n. This will give you a resonance. So the resonance, if you go to the amplitude, you will see that the amplitude will be here. Amplitude will be maximum here. It may go to infinity hatta. So excessive vibration is induced, resulting in large amplitude of vibration owing to resonant conditions. So what we do in this case, Shabab, what we do in this case, we will put an absorber. You are forced to work here in this region. Let's say at 1,500 RPM. And unfortunately, in this region, there is what we call resonance. So all we have to do is to add a spring and mass. And to add the spring and mass is like this. If we have to work, this is the question, if we have to work in this frequency range, situation can be alleviated. We can alleviate the problem when the system properties, mass or the spring constant are changed. If we can't change their position, we alleviate the problem. So what we'll do, we add a spring and then a damper. This one here, I'm adding a spring and then mass. Spring and then mass. If I add the spring and then mass here, so I will have 2 degrees of freedom. I will have X for the original system, and I will have XA for the absorber. So I am adding just a mass and then a spring, which is this one. You don't need to go through this theory now. I will explain to you just the phenomena. So if we add this one, this is what we get, Shabab. This is what we get here. At the frequency, when I add the damper, when I add the spring and the mass, this is what we have. The solid lines, the solid lines. As you can see, at the frequency range, the vibration now is coming, the amplitude of vibration is 0. I reduced the vibration to 0. But as you can see, I created 2 other resonant frequency. One is here, the other one is here. Now, my question is for you, did I solve my problem or not? Now, this is, if you remember, at 1,500 RPM, we said, this could be at 1,800, and this one is at 1,200. Now, when I put my absorber, the mass, and then the spring, I have now the vibration is coming 0. Did I solve my problem or no?
Yes.
I think no, because now we have 2 vibrations. Point.
One by one, please. One by one. الرميح كان يتكلم. الرميح تفضل. Yes, can you explain to us why and how?
Yeah, because we will operate in 5,000, 1,500. So we will not be at risk. And they are, far away from 1 ratio.
Yeah. We created here how to avoid this one. كيف نتجنب هذه 1,200 and 1,800? كيف نتجنبها? How do we avoid
another? We put another, the same thing.
Okay. Right. Any other answer? You will see the answer now. You will see. Any other answer, Shabab?
Yes, I think we should make a vibration at 4 or not at 0, because when we make it at 0, we have 2 points of vibration.
No, this is not the case. Look, when we had no absorber in the beginning, see the dotted line. The dotted line were giving you resonance and high amplitude. The dotted line. The dotted lines are without absorber, the red ones. Now we put an absorber. See, we avoided the resonance here. We avoided the excessive vibration. It's becoming 0. But we created 2 other resonant points. One is here, omega 1, before the operating point, and one after the operating point. My question is, did we solve the problem or not?
I think no.
Rumeh, he said, yes, we did solve it. But I don't know if you agree with him or no.
I think we didn't solve it.
Yeah, we solved it, but we have created another problem.
Any other answer, Shabab?
Yes, maybe we should put the absorber in another point.
Any other answer, Shabab? Any other answer? So no other answer. Let me show. In fact, Shabab, we solved the problem 100%. Why? Because your machine, when you want to start your machine at the startup, you just pass this one quickly, tick, 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 tick. You will go to 1,500. And you are working here, you are safe. And you have nothing to do here at 1,800 RPM. This is not your range and not your frequency range. So you have nothing to do there. So the problem is solved 100%, and you don't have to worry. Everything is under control. Let me just show you one small video that shows you how the vibration absorb the vibration that was coming from the absorber. The absorber will take all the vibration. Your system will not vibrate as if it is stationary. It shows here now. It shows, as you can see, that the amplitude of vibration is 0. So let me just show you one small video here. I think you can, if we can see it. Let me go here and then say share application. I hope it will work, inshallah. ادعوا معي يا شباب, it will work, inshallah. This one, maybe. Do you see it, Shabab? Do you see anything?
Not yet. Yeah.
No, it's not coming. It's not coming. No, not this one. This is not what I want to share, but let me try again. I don't know, this blackboard is crazy, and one of these days he will make me crazy with him. Let me just try. زي واحد العجوز تكلم ابنها تقول لها الواد ده مجنون وحيجنني معاه.
Just Doctor, to clarify this problem, you shared the Google Chrome, right, application. So if you go to Blackboard tab or window, it will show the replication of what's showing in the Blackboard.
I'm in Blackboard now.
No problem.
Do you see this one?
Yeah.
See anything?
Yes.
Do you see the mass vibrating mass?
Yes.
طيب شباب, this is what we have. تشوفوا هنا the K1 and M1 is the original mass. K2 and M2 is the absorber. See now, if I increase the mass, see the vibration is coming. And see, I am going away from now they are both moving. So you need to adjust them in such a way that this vibration of your first original system, M1 and K1, will not vibrate. So you can increase the force if you want the amplitude of the force, you can increase it. You can increase omega, this is your system. But see the frequency range, where are you now? You are far away. See when you approach the resonance, see what is happening. Do you see this phenomena, Shabab? You see these masses, how they are moving? So now if I just move a little bit, now see when I am at the original, So the frequency, this one as if it's not moving. Now I will adjust my M2 and K2. I will adjust them in order to have 0 vibration. So this one as if it's not vibrating at all. It is vibrating with small amount, but you can adjust K2 and M2 in such a way that the vibration will be 0, reduced. So you can play with this one. This we can make it. We can make it as an experiment for the, inshallah, next lab. We'll make it an experiment. We will play with this parameter here. When we increase the mass, the K, and then M, you will see what is happening here. You will see the amplitude, X1 over X2. You will see X1 is equal to what? X static deflection is equal to what? K1, M1, and omega 1 and omega 2. You see all this ratio, and you see how this one can be reduced. The vibration, how it can be reduced just by playing with the mass and then the spring.
Victor?
Yes.
Can I increase the range of resonance? I mean, we have 2 peaks of resonance, right? Can I make them far away from the resonance?
Yeah, just by playing. Usually the mass we cannot play with it. We can play with the stiffness. You can. Some people they adjust the pendulum, a small pendulum. They add it to their system, and it will. You can play with the stiffness of the system. واضح شباب? Is it clear? Any question you have? Any question? Any question? I think today I will release you early because we finished for this chapter. Inshallah, we'll start chapter 10. If you have any question for this chapter, you are most welcome. I will solve some problem, maybe because this will come in the final exam. Some problem in the final exam will come. So these are the some applications of the control or controlling the vibration that is coming from the motion from the ground or the motion from the car. So basically, we solved our problem, and this is what we are saying, you know. Amplitude of vibration at working frequency range is eliminated. Frequency range is eliminated, is becoming very small. The lower natural frequency must be passed at startup. أنت تبغى تشغل الماكينة مع الصباح أو stopping, leading to large amplitude vibration during these transient periods. إذا تبغى كمان توقفها, you will just تمر على هذه في العودة في المساء وتمر عليها في الصباح إذا جيت تشغلها. Higher frequency range cannot be reached in our working frequency. I will stop here. I'll take the attendance, and if you need any help, any question, just let me know. So you need to go and prepare for your exam. We finish this chapter 9, شباب. Inshallah, we'll start chapter 10 tomorrow بإذن الله أو بعد tomorrow بعد غدا إن شاء الله. علوة منير. أهلا منير. بغالبي فيصل. فيصل شكله راحت عليه نومة. فيصل أوكي.
يا دكتور.
أهلين فيصل أهلين. مسعودي عبد العزيز. عبد العزيز المسعودي. أهلين.
عبد العزيز المسعودي.
أهلا وسهلا عبد العزيز. أنا ناديتك كذا مرة. ما المولى ماجد.
موجود دكتور.
أهلا وسهلا.
اهلا بك.
ماجد أنا أنطق اسمك غلط ولا صح؟
لا صحيح.
أوكي. القحطاني حسين. أهلا شيخ حسين. محمدي عبد العزيز. القحطاني عبد الكريم مشبب. الشهري علي. الشهري علي. الشهري علي. علي الشهري. الرميحاني.
Yes.
القرني علي. الشباب اللي يبغى يمشي، إذا خلصت اللي يبغى يمشي. الزهراني فارس حاضر. الحمدان عبد العزيز. سيدة محمد، سيدة محمد أهلا وسهلا. العجمي مبارك، طليحي يوسف، الزاير حسان، الجهني نادر، الجهني نادر، نادر جهني، نادر الجهني، العقيل رائد، العقيل رائد.
هلا والله دكتور، هلا والله.
هلا والله هلا. الدرويش عبد الله، الدرويش عبد الله، عبد الله الدرويش ما هو هنا اليوم. شرفنا حسين، حسين الشيخ حسين، كيفك يا شيخ حسين؟ الدبيس علي
موجود
الدبيس
يا دكتور.
اهلا وسهلا. المحمدي سلمان، سلمان كيف حالك؟ البشر علي
موجود يا دكتور.
اهلا وسهلا. الجارودي حسان كيف حالك؟ محمد اهلا وسهلا. الرشودي. الهاشم ناصر
يا اهلا يا دكتور.
اهلا وسهلا. العواد سلطان، العواد سلطان، العواد سلطان. السوبدي علي، السوبدي علي كيف حالك؟ عبد اللطيف، عبد اللطيف، عبد اللطيف كيف حالك اليوم؟ عبد رب النبي موسى، موسى كيفك؟ زهراني عبد العزيز، عبد العزيز زهراني اهلا عبد العزيز كيف حالك؟ العتيبي فهد، العتيبي فهد موجود؟ فهد العتيبي. محمد يزيد اهلا شيخ يزيد كيفك يا شيخ يزيد اليوم؟ خباز منتجب. الصبحي نايف، الصبحي نايف، الصبحي نايف. طيب مين ما سمع اسمه؟ خلينا ننادي مرة ثانية. الجهني نادر. درويش، درويش، درويش ليش يا أخي؟ كنت كذا مرة ناديتك الله يرضى عليك. الجهني نادر موجود؟ نادر الجهني، نادر الجهني. يلا شباب اتمنى لكم التوفيق وحاولوا تراجعوا الامتحان، تراجعوا التمارين اللي حليت لكم اياها وان شاء الله اتمنى لكم التوفيق. راح يكون في اعلان افويد تستخدموا هذه الامرجنسي ابلود لانه راح ينقص منكم 5 درجات. submit on time. عبد الله الدرويش اوكي ما في مشكله انا حضرتك. الجهني نادر موجود؟ الجهني نادر نعم تفضل.
الاختبار
حضرتك فهد. الشهري علي اليوم مش موجود ما حضر معانا. فهد العتيبي حضرتك ما عندك مشكلة. الجهني نادر، الجهني أشوف اسمه هنا موجود بس هو ما يرد. تفضل يا سلطان العواد. Yes you have something.
بس بتأكد دكتور حضرتني؟
أيوة حضرتك.
جزاك الله خير.
الله يسلمك.
الدكتور أنا عندي سؤال.
تفضل.
الفاينل هو بيكون كومبرهنسيف ولا بس بيكون ماتيريال الفاينل؟
أعتقد راح يكون ماتيريال فاينل لأنه زحمة كثير وتشوف فما راح دونت ووري في كل شيء في أوانه يعني إن شاء الله بإذن الله.
طيب وميجر 1 نقدر نشوف السوليوشن حقه ولا ما يمدينا؟
والله اشوف احضر السولوشن وانه نحطها لكم ما عندكم مشكله.
خلاص
اللي عنده اي شيء ما عنده مشكله.
يعطيك العافيه دكتور.
العافيه. السلام ورحمه الله. يا نادر الجهني نادر اشوفه هناك بس ما يكلمني. نادر يا نادر الله يرضى عليك، الله يسامحك. انا خليتني حتى صوتي بح، يعني صوت وانا من كثرة الند لازمني الان عسل وشاي احمر وما ادري اذا طيب على خير. يلا نشوفكم على خير ان شاء الله شباب.